urban noise pollution is affecting both commercial and residential areas. Traffic noise, especially during rush hours, impacts health, causing stress, sleep disturbances, or cardiovascular risks. Our project monitors noise levels at a traffic intersection in Bandar Baru Vangi. The focus is how traffic light phases influences noise pollution. IoT-based system collects real-time data via cloud platforms like Think Central and Think Speak. Unlike traditional methods, this approach captures dynamic noise variations instead of just long-term averages. These findings help city planners create better noise management and traffic strategies. It supports smarter urban planning and future smart city innovations.
Here you can see our friend Darien is putting the gateway out of the bag. The gateway is the ESP32. And now he's connecting the jumper to the gateway. Second, and the red one is the third one. We have two jumpers for the energy supply and one jumper for the connection, the red one. And now you can see that he's putting the noise sensor out of the bag. This is the KKKM6043 noise sensor. And now he's connecting also the gateway through the jumper with the sensor.
The black and white cable are for energy supply, and the red cable is for transmitting the analog data from the sensor to the gateway. Now we connect the gateway to the laptop for power supply and to upload the Arduino code onto the gateway.
In the end you can see a red light, so you can see it's working.
For our measurements, we will choose a spot somewhere around this junction. Here you can see our setup. The setup is 4 meters away from the street and approximately 50 meters away from the middle point of the junction. In this clip, the cars next to us are waiting and the cross traffic has a green light phase.
Next scene, the oncoming traffic gets the green light phase, while the cars next to the sensor are still waiting. This scene is the most important one for us and our project because the traffic next to the sensor has a green phase and our sensor can measure it most effectively.
The noise levels were recorded at a busy intersection in Bandar Baru Bangi over 1 hour, from 3:51 p.m. to 4:49 p.m. The sensor data was collected using ThinkSpeak and Think Central cloud platforms.
The noise intensity values fluctuated between 1700 and 3500, showing periodic variations. While ThinkSpeak provides a cleaner structured visualization and uses simplified time labels and marker points for clarity, ThinkCentral offers detailed timestamps for precision. The graph is denser, making trends harder to interpret. In the red light phase, vehicles remain stationary, leading to lower noise levels. Some minor noise fluctuations were observed due to idling engines and ambient sounds like wind. In the green light phase, the vehicles accelerate simultaneously, causing sharp noise peaks. High noise levels were detected, especially due to heavy vehicles like buses and trucks, or due to motorbikes.
So this is the conclusion and the limitations. Our study findings are that noise is the loudest during green lights because the cars speed up. Noise is lower during the red lights when cars stop. Traffic light timing affects city noise levels. We use ThinkSpeak and ThinkCentral to collect, display and analyze noise data in real time. The advantages here are: it works automatically, can handle large amounts of data, and it's better than old methods. The challenges here are the background noise, our sensor equipment because we used low equipment, cheap equipment, and our setup, the placement of the setup. Also the weather conditions were a challenge. For the future I can say that AI can predict noise levels and busy times and also control the traffic lights to reduce noise. So, our limitations were, for example, that we only use basic sensors. Better ones are very expensive. We also had no direct decibel measurements, only analog values. The background noise also affected our data and we didn't use any filter. So I can say there is very much space for improvement.